Module, we are going to study Cartesian sign convention. Let's understand what do you mean by the word convention. The word convention, it means rules. And this Cartesian sign convention, students, was given by Sir Descartes. To understand Cartesian sign convention, let's consider a graph. You're all familiar with the graph, right? A graph has two axes. First, the horizontal line is called as the x-axis and the vertical line is called as the y-axis. Now, the x-axis and the y-axis, the place where they intersect is called as the origin. Now, students, distances to the right of the origin are considered as positive. Distances to the left of the origin are considered as negative. Distances measured above the origin are considered as positive, right? And the distances measured below, that is here, that is considered as negative. So basically, we have this positive and negative side on the x-axis and y-axis. Now students, what I do is, I place the mirror in such a manner that the pole of the mirror coincides with the origin of the graph. So students, I can call this as the pole, or I can also call it as the origin. Next, here this is behind the mirror, so the one that is opaque side is behind the mirror and the one that is reflecting side of a concave mirror is in front of the mirror. Then we all know C stands for center of curvature and F stands for focus. The same graph, I'll place it over here, and now let's come to the Cartesian sign convention. Let's see, this is the left side of the graph and the other side is the right side of the graph. And we all know that we have seen the ray diagrams. In all the ray diagrams, we place the object to the left side, right? So the first point, it says object should always be to the left side of the mirror. Next, I'll place the image. Let's assume that the image is behind the mirror. That is a virtual image, right? The image is named as A dash, B dash. This is the image, right? Now the second point, it says all distance parallel to the principal axis are measured from the pole of the mirror. So whenever you want to measure anything, you have to measure it from the pole. From the pole, it means from the origin. So all the distances, object distance, image distance, everything you will measure it from the pole. Next, the point says the distance to the right of the origin are positive. So according to the graph, right side is positive. We say that the distances to the right of the origin are positive. So students, if I get an image to the right hand side, that is a virtual image, then I will say that the image distance is positive. But on the other hand, distances to the left of the origin are considered as negative. So students, we all know that object is always placed on the left hand side, right? So the object distance, students, will always be negative. Now, if I get a real image, a real and an inverted image, I will get it on the left hand side, right? So that time, the image distance will also be negative. So it depends. Object distance is always negative, but image distance, if it is to the right, it will be positive. If it is to the left, it will be negative. Next point, students, it says the distance measured perpendicular to and above the principal axis are positive. So if you see here, the image height and the object height. Here the object is straight, erect, right, above the principal axis. So the object height will be positive. And the image height, student, it depends. If the image is virtual and erect like this, then the image height is positive. But if I get a real and an inverted image, if it is an inverted image below the principal axis, then you say the image height is negative. Here the image height is positive, right? Like the next point, it says the distance measured perpendicular to and below the principal axis is negative. So I told you, if the image is real and inverted, then the image height will be negative. The next point, it says focal length of a concave mirror is negative. Now let's see why the focal length of a concave mirror is negative. Here we place the concave mirror. Now student, if this is the concave mirror, then here you can clearly see the focus is on the left hand side. When the focus is on the left hand side, focal length, that is distance from pole to the focus, is also on the left hand side, so focal length of concave is negative. Let's see for convex. The focal length of convex is positive. Why positive? Because the focus is on the positive side, right? When the focus is on the positive side, obviously the focal length also, if you measure, that is on the positive side, and we say the focal length of convex is positive. So here we complete Cartesian sign convention. Let's move further to important formulas that we are going to study. The two important formula is, first one is mirror formula and the second one is magnification formula. Let's start with mirror formula. The mirror formula, it involves three terms. First is V, second is U, and the third one is F. You're all familiar with the small f. It stands for focal length, right? Let's understand what you mean by V and U. V stands for image distance. It's small v, students. Small u stands for object distance. And finally, small f, it stands for focal length. So we have V, that is image distance, U, object distance, and F, focal length. And the mirror formula is 1 upon V plus 1 upon U is equal to 1 upon F. Coming to the next formula that I told you, magnification, capital M. Let's understand what is magnification. Magnification is equal to size of the image H2 upon size of the object H1. So the magnification formula is H2 M is equals to H2 upon H1. This H2 and H1 can also be written as size of image is given as H dash and size of object is H. So the formula can also be M is equals to H dash upon H, and which is also equal to minus V upon U, that is minus image distance upon object distance. So the M formula is M is equal to H2 upon H1 is equal to minus V upon U. So that is magnification formula and mirror formula.